Okay, we're going to work through several of the exercises in exercise set 5A. The quiz only covers material from exercise set 5A, simple derivations. Okay. What you're going to see on the homework is a list of premises listed sequentially, and then slash, and then the conclusion. All right, so here's the first one. P arrow Q, Q arrow R arrow S, and then the conclusion is S. Now, what I've done on the quiz is just list the premises in numbered order. Okay? Premise 1 is P, premise 2 is P arrow Q, premise 3 is Q arrow R, premise 4 is R arrow S, and the conclusion is S. Okay, the conclusion is S. So you need to follow the pattern to draw inferences from these premises to arrive at S. Now, what are you going to be looking for? You only have two. You have arrow argument patterns, two of them, and you have an or argument pattern. So you're always going to need to use an arrow statement and then half of it, or an or statement and then half of it. Something happening with half of it. Either it's affirmed or denied, depending on the pattern. And so you have some guidelines here of how to proceed with these three foundational rules. Okay? And again, this one reflects how we would reason through this. Well, if P implies Q and P is true, then Q is true. And if Q is true, then since Q arrow R is true. And since R is true and R arrow S is true. And that's essentially how our argument is going to proceed. Now, we don't have any complicated, what we call when something follows a pattern, when a specific proposition follows a pattern, we call that a substitution instance of the pattern. And in the last video, when I dealt with negations and everything, I was dealing with more subtle or complicated substitution instances of the pattern. But here we have pretty straightforward ones. Okay? Notice premise order doesn't matter. We have an arrow proposition and we have the antecedent affirmed. Okay, so line 5, and in the quiz I'm going to try to tell you how many steps you could do this in. Now, you can draw correct inferences, right? In most of these there's going to be one pretty direct route, but often there's several routes, and if we got more complicated there are. So all that matters is that you proceed correctly and reach the conclusion. I'll give you a suggestion about how many rows it might take. P arrow Q, P, therefore Q is true based on lines 1 and 2 and the modus ponens rule. This is a substitution instance of modus ponens. P arrow Q, P, therefore Q. Now we can have Q follows from these initial premises. And we've shown that it does based on our rules, right? I've already given us a verbal reasoning that S follows from it, but we don't have rules to show that directly. We break it down to show this pattern. Now we've got this. Do we see this anywhere in antecedent and anywhere plausible? Yes. Q arrow R and Q. You see, doesn't matter where the statements are. Any of these 5 statements, you can use 2 to find a new pattern. Q arrow R and Q, therefore R, following lines 3 and 5, and the modus ponens pattern. I'm going to come up over here for line 7. Now that I have R, and I have R arrow S, I again can deduce S. And that's my conclusion, right? This is your goal, okay? Using 4 and 6 modus ponens. 4 and 6 modus ponens. Notice I always have two lines I'm appealing to here. S is true based on lines 4 and 6 modus ponens. Okay? This is the inference you're drawing. This is what we call the justification. Where'd you get that inference from? And what rule did you use? Justification. Where'd you get that inference from? Which premises did you use? Which rule did you use? Okay, which premises, which rule? Okay. Again, don't be tempted to say, well, I got S by going from and put all the lines 1, 2, 3, 4, 5, 6. No, it's not sequential like that. Once you have Q, that's in the bag. So where do you get R based on these 5 statements? I get it from line 3 and 5. Okay. So that's when you reach here, when you reach your conclusion, your derivation is done. You've derived the conclusion of the original argument from the premises using these rules. As these get more complicated, it can help to work backward from the conclusion. All right, I need to get to S. Where does that? All right, so I'm probably going to need R. How do I get R? Well, and you can kind of work backwards. That's a procedure. To know what you're going to do, of course, you have to work forward to do the proof. Okay, so that was number 1. Let's do number 2. That does this, but with some modus tollens. Right, here we go. we have the same conditional statements, P arrow Q. And I'm going to erase this so we're not confused. P arrow Q, Q arrow R, R arrow S. But now we've got fourth premise, not S. Since S is false, R is false, and that's how that's going to go. And so our conclusion is not P, which is the negation of this antecedent. So think modus tollens. All right? Since S is false, R is false, and since R is false, Q is false, and since Q is false, P is false. Is how this is going to go. All right. From 3 and 4, I can deduce that R is false. R implies S, right? Richard implies Sam, but Richard is here, Sam is here, but Sam's not here, so Richard is not. How did I get that reasoning? I use lines 3 and 4 and the modus tollens pattern of reasoning. Why do I only have 2 lines? Because those are the lines I use to get the inference. When I have my next line, right, this inference is done. I don't go 3, 4, 5, 6, All right, let me show you what I mean. Since R is false and Q implies R, Quincy implies Robert, but Robert's not here, so Quincy's not here. That's lines 2 and 5, not 3, 4, 2, and 5. It's lines 2 and 5. Modus tollens again. 2 and 5, modus tollens. Modus tollens is always a 2-premise pattern. So if you're writing more than two lines here, you're not thinking about it right. Okay, I made this inference, so now I know that not R follows from these premises, so I appeal to that and some of the other premises to derive not Q. 2 and 5. Okay. 7, since Q is false and P implies Q, P is false, which is our conclusion. You don't have to do the circling, I'm just showing you. Okay, and that is from 1 and 6, and again, modus tollens. Okay, so these first 2 only use 1 argument pattern each. Many of these will mix argument patterns. So let's look at some of those. Let's look at number 6. I think I have a similar one on the quiz. Yeah. Let's look at number 13. 13's a good one. We'll go back to some of the other ones. I know that looks like it's stepping forward, but it's actually pretty straightforward. P or Q, it's premise 1. Okay. Q or R, and then we'll deal with some of this double negation stuff. Not R, therefore P. Okay? And again, you've got some OR statements. You always need an OR and arrow statement, and you need a, sorry, this is Q arrow R. This is Q arrow R. This gives us our mix. So you got some arrow statements, an or statement, and you're looking for half of it, affirmed or denied, right? Aha, not are, right? So these are the two you're zeroing in on. Q implies R, but R is false, so Q is false. Now we've got this not Q can be matched up with this. One of these is true, but Q is false. You see how this is Q? This is critical. This is Q. This is not Q. Since Q is false, P is true, and that's our conclusion. We got not Q using lines 2 and 3 and the modus tollens pattern, right? Arrow statement, deny the consequent. Therefore, we deny the antecedent. And then here, notice what we're doing, right? This is an inference, it's a conclusion, but we use it as a premise in a new argument. This is the power of deductive argument. P or Q is true, but Q is false, so P is true, which is 1 and 4. And if you're paying attention, this is MTP2. We denied this right half, and so we affirm the second half. Okay? So there is a combination of modus tollens and MTP. Okay, let's deal with some double negation stuff. More complicated inference patterns. And we're going to do compound parts here. Okay, let's do number 10. Not P arrow Q. Premise 1. All right, remember, of course, that not just applies to P. You can always look for your main connector. Not Q. R or not P. And the conclusion is R. This is a fun one. All right, R. Right, so you're seeing where you have to detach that R. Okay, you have to do something. Okay, now watch what happens here when we have negations right here. Here's an arrow statement. Here's your antecedent. Here's your consequent. Premise 2 denies the consequent. It's Q, not Q. Okay, so we have A implies B, not B, right? To go the other way, right? That's the substitution. Therefore, this is false. Therefore, not P is false. That's where you get your double negation. Okay? So that's 1 and 2 modus tollens again. Okay? And since this is already negated, we have to negate it. We have to do the double negation. Now look at what this not P is. It's this negated. It's not P negated. So we have an or statement, and this is negated. So that follows our MTP pattern. Since this, not P, is false, i.e. P is true, but we're writing it out in this formal way, that means R is true. Since not P is false, since this half of the or statement is false, this half is true. So we get our conclusion R by 3 and 4 MTP. And again, it's MTP2 because we denied the second half. Okay, a couple more. And that'll be it. Okay, I want us to deal with some where we have compound parts in your arrow statement within, like as the consequent or antecedent. Here's what I mean. Like number 14, not P, arrow, Q, or R. Wow. Okay, but it's still an arrow statement with antecedent and consequent. A, arrow, C, if you want to do it that way. Okay, not P is your antecedent, Q or R is your consequent. That's premise 1. Premise 2 is more straightforward, P, arrow, Q. As you're doing these, right, when he writes them, right, he puts a colon, semicolon between each premise. So make sure you don't run through the premises. You'll confuse yourself. Okay? 11 would be a good one to do with these two. We'll do that one next. Okay? P arrow Q is premise 2. Not Q. Okay, so we've got that nice modus-tones relationship. You should start to recognize that. Therefore R. Therefore R. Okay. All right, we have that modus-tones relationship, right? So although you have something more complicated, you can break this down. 2 and 3 follow the modus-tones pattern. Very straightforwardly. Not P from 2 and 3 modus-tollens. Now we've got not P, which is our antecedent here. Okay? Not P, not P. Not P implies blah, blah, blah. Not P, therefore. Therefore, you have to drag and drop this whole consequent, Q or R, by lines 1 and 4 modus ponens. And now look at this is a fun one to me. 1 and 4 modus ponens. Notice we use modus ponens even though we had a not P, because it's not P, not P. Affirm the antecedent. Affirm the antecedent. I know the video's still going, but my screen went into sleep mode, so I'm going to, so I can see what I'm doing here. Okay. Okay. Not P implies this, and not P, therefore this. Right? If Peter is not here, then either Quincy or Robert are here. Peter isn't here, so either Quincy or Robert are here. Okay? That is a substitution instance of the modus ponens pattern. I didn't mean to come back on the screen for effect. That is a substitution instance of the modus ponens pattern. Get that? That is a substitution instance of the modus ponens pattern. Antecedent implies consequent. Antecedent is true, therefore the consequent is true. Okay. Now, right, that consequent has detached is an or statement. Q or R, not Q. Now it can be used in the MTP pattern. Q or R, but Q is false, so R is true. Right? So this argument is if Peter is not here, then Quincy or Robert is here. And if Peter is here, then Quincy is here. Okay? Peter's not here, one of these is here. Peter is here, then Quincy's here. But Quincy's not here, and that leads to your domino effect. That means Peter's not here, because if Peter is, Quincy is, but Quincy's not. That means Peter's not. That means this takes effect. But because of the interrelation, we already got the Quincy's not here. Right? So since one of these are here, and it's not Quincy, it's got to be Robert. Okay? Now we got directly to that. This last step is using 3 and 5. If you want to write 5 and 3, that's fine too. 3 and 5, MTP, and it's MTP 1. Okay, this is a good one. This shows the power of this, right? The relationship of inferences. What does and notice what remember what a valid argument does. It restricts the truth conditions it says we're in. It says, right, when we satisfy these things, right, we're restricted the truth conditions. We got to deal with Quincy's not here, right? Again, those of you LSAT people, right? That's what the initial specifications give you, right? You can't put so-and-so next to so-and-so, right? Those lay out your conditions. And of course, in actual law, right, that's what a contract does. Here's the conditions that have to be met. Here are the facts. Okay, Quincy's not here. If Peter's here, then Quincy is. And if Peter's not here, then one of these are. Right? The interrelation between those leads us to R. Okay. One or two more. I said 11 was a good one to do on this score. Let's do 11. And that might serve us. I think. Okay. Not P, premise 1, not P implies, parentheses, not Q or R. Okay. Now notice how I read these as I write them. That'll help you, right? That helps you kind of capture what's there. And I tend to use implies for the arrow to capture this logical relationship. Not P implies not Q or R, right? That gets in my head that not P is the antecedent. Not P implies not Q or R. Okay, premise 2. P implies R. Premise 3. Not R. Okay. and the conclusion, not Q. Now, regardless of some of these complicating things, you got a negation here, you have a compound thing here, you're always going to have kind of a nice entryway into the argument. There's got to be some entryway. Negated, consequent. You're in business. Not P. Again, using 2 and 3 modus tollens. Right? And since P is false, again, we have this antecedent. Right? This follows a very similar pattern, which gives us not Q or R. How'd I get that? Here's your antecedent. The antecedent is true. So the consequent, this whole thing is true. Drag and drop. Drag and drop. Not Q or R is true. I'm going to try to stop this. Moving out off screen here. Okay. Not Q or R is true. Okay. Now this is an OR statement just like before. Notice we have an OR statement and we have not R. Since not R is true, since this is false, this is true. Not Q, based on 5 and 3, or 3 and 5, MTP. It's MTP2. Forgot to give the justification here. This is modus ponens. You don't have to do all the symbols. I'm just doing this to guide us here. Right? If-then statement, antecedent is true, therefore the consequent is true. So this is 1 and 4 modus ponens. 1 and 4 modus ponens. And again, we've gotten to our conclusion. Not Q, not Q. All right. Combo. Look, this uses all 3. This uses, like the last one, uses all 3 argument patterns. Let's do number 9. Just to give, again, in your head the idea of different kinds of substitution instances. Premise 1, P implies Q implies that Q implies R. If P and Q is true, then so is Q implies R. If this is true, if it's true that Peter implies Quincy, then it's also true that Quincy implies Robert. Now that's a complex statement. If you think about what it's equivalent to, it does make sense to say it, right? If we don't get Peter or we get otherwise we get Quincy, then if we get Quincy, then we get Robert. Right? It's a domino effect. Okay. 2. Premise 2. P does imply Q. Okay. Right? It might be weird. You might think weird to say, why are you making a conditional statement antecedent? Because you don't know, right? Like, you know, think of the scenario, right? You're not sure if Peter implies Quincy. You don't know what's going on. But someone tells you, yeah, Peter's bringing Quincy. So if we get Peter, we get Quincy. Right? And then we're saying if that's true, we're going to get Robert, right? I don't know what the thing is where if Peter's going, then we definitely get Quincy, right? And if Quincy has Peter, then he's going to bring along Robert, right? And maybe there's other ways to get, you know, again, if then is not only if, right? But this is the scenario we're in. P implies Q. And premise 3 is simply P. And we get Peter, right? So we have this nice, right? So the conclusion is going to be R. Where again, you're going to detach this half and then use it in another argument as the arrow statement, right? Peter implies Quincy, and Peter is here, therefore Quincy is here from 2 and 3 modus ponens. Okay. Also, Peter implies Quincy, right, is the antecedent here, so we can use 1 and 2 to derive Q arrow R. Now notice you could have done this in the other order. This is 1 and 2 modus ponens. P implies Q, blah, blah, blah. P does imply Q, so Q implies R. If you had done this in a different order, you give total full credit. Okay, that's what I mean. Sometimes you have different options, right? But either way, we end up with Q, and we end up with Q implies R, right? Which itself follows the modus ponens pattern, which gives us R by 4 and 5 Okay. I'm going to think about putting an announcement here somewhere in there on the homework. This procedure is doable, but if something doesn't click about, okay, what are these subsequent lines? How do I use the rules? There's a chance for your 10 homework exercises to be a mess. So watch these videos early, reach out if you're stuck or don't have it really 100% nailed down.